Hello, welcome to Courser Capstone project. My name is Pavan. About this project, it is electrical energy output of a combined cycle power plant where we have five columns. Out of five columns, we have features like temperature, ambient pressure, relative humidity, excess volume, and the output is energy output. Here in this session, I would like to explain how did I done my model building and how did I choose the algorithm and my approach, and I will walk you through my coding and my findings. The first, initially I have imported all the required libraries for this project. We need pandas, numpy, matlab for drawing the chart, so like that. Next, I have imported the data that I have received it as a input in CSV format. So this is how it looks. It has, by default it has uh, headings like ATV, AP, RHPE. So I have renamed it to temperature, excess volume, ambient pressure, relative humidity, and energy output for better understanding. After renaming it, this is how it looks. It is having total 9568 rows. Oh, so we have enough rows to investigate. And here I can see it is data is distributed in decent manner. Most of the data lies in 50%, so that's what I identified here. And there is no null values in the any of the column. They're all having some values. That is also good. If I if I uh, if I view it, if I print it in a visualization format, this is how it looks. And next important is correlation. When I see the correlation, I can understand that temperature and exhaust volume are negatively correlated with the output here, which is energy output, and the rest are fine. The same thing visually we can see here. This is negatively correlated, whereas the rest is fine. There is also another way known as a heat chart to see the correlation. Here also I can see for temperature and exhaust volume, it is negatively correlated with the energy output. I have printed the same. Now I am splitting the data into two sections, train and test data. And I can draw how the correlation for test and train data with respect to temperature for the target value, which is energy output. So here I have identified that we have more than one feature here: temperature, exhaust volume, ambient pressure, and relative humidity to predict the output. Here our target is energy output. Since we have more than one, according to theorem, we shall use multiple regression model. So I have opted to use multiple regression here. So I have imported linear regression with sklearn library, and I'm fitting it x and y, where x is all the features: temperature, excess volume, ambient pressure, relative humidity. I can see the coefficients are like this for each feature. And when I print the variance square, it is 0.92, which is good. Residual sum square is 22.48. This is what I have seen after building the model. The same thing I am printing everything in one section here. Now after that I need to see the error matrix. So we have a lot of error matrix. that we have trained in this course. So first one is a mean square error, also known as RMSE, sometimes used as a RMSE. Here is the mean square error. We have 22 point something here, and then absolute error is 3.47. So mean absolute error, I have used sklearn matrix to calculate the mean absolute error and then mean absolute percentage error. This is 0.008, which is also good. Now it's time to determine the coefficient of r square. R square score we can also say like that. That is 0.92. So overall, this error lies between 0 to 1. So by this way, I can conclude that we predicted in better way, and the model is best fit, and algorithm is apt for the given example where we have more than one feature. Okay, thank you.